Hi, all JEE NEET aspirants. Hope you all preparing well for JEE NEET examinations. Before entering into the lecture, just give me a few seconds of your time. I started a series of episodes on JEE NEET previous year papers, and you are also going to get concept lectures in future. Our aim is to make you score 100 percentile from chemistry part of JEE NEET examination. I hope it cheats. I proudly say that you never get the basic conceptual analysis before as Chem Masters gave you. So from each and every problem, you can learn concepts which helps you to solve many kind of model problems. Hence, my request is to you that watch the video completely and learn the best concepts to solve any kind of problems. So do subscribe, like the videos, share the videos, and here my request is that your responses only encourages me to give you a lot. So please do subscribe, like, and share the videos. And if you are interested, you can join the website chemmasters.online to get care coaching on JEE NEET chemistry. Okay, right. And here we are going to analyze 2019 NEET reconducted exam paper. So here we are going to analyze 22 questions of 2019 exam. So as a part 1, in part 2, you are going to get all the remaining questions. Okay, right. Now just start. The reaction that doesn't give benzoic acid as the major product. This is the question. Okay, right. So if you have the basic knowledge, we can simply say that alcohol, whenever reacting with K2Cr2O7, it converts alcohol into carboxylic acid. Okay, and in the second case, here it can also give carboxylic acid. Okay, so we can discuss in detail later, but just check the options here. Okay, so methanol, whenever reacting with PCC, that is pyridinium chlorochromate, which convert alcohol into the primary alcohol into aldehyde only. Okay, here the primary alcohol reacting with KMnO4 also produce carboxylic acid functional group. Okay, so which is the correct answer here? We can simply say that third option is the correct answer. Okay, so if we have the basic knowledge, we can simply choose the option, but it is important to look at the concept, that means a mechanism, how the reactions takes place. If you understand the mechanism involved in each of the reaction, then you can solve any kind of model problems on these oxidations. Okay, right. Now just look at the first one. So my request is just watch the video completely and stay with me because it may get some time. You need to have patience. Okay, right. So just draw alcohol here. Right. Now K2Cr2O7, can you expand its structure? Just do it. O minus K plus. Okay. So this is K2Cr2O7. We know that K2Cr2O7 is an oxidizing agent. Okay, right. In a first step, the lone pair of electrons on hydroxyoxygen attack on chromium. Okay, right. Now just draw the next step here. I'm just taking simplification here, just taking pH. So CH2O. So here oxygen donated its lone pair of electrons. That's why we can write plus charge on oxygen. Now chromium, so not here, just draw here, okay? Then O minus, so this is the first step. Now what happens? The H plus simply cleaves from it to compensate the positive charge on more electronegative oxygen. Okay, right. Now here the loss of H plus. Just say this loss of H plus takes up by this negative charge. Okay, right. Now just draw the next step. O minus, K plus. Okay, now here OH. In the next step, what happens? Simply one of the proton losses and bond cleaves here. This double bond electrons moves on to more electronegative oxygen. Here you get PH, C, double bond O, H. Okay, and in the next product you can get like this. I'm just drawing this chromium here. Okay, so just watch it carefully. O, here is the chromium, and already it is having one hydroxy group. Okay, and one with salt, we can say O minus and K plus, and another one with O minus. Okay, once again the lone pair of electrons on carbonyl oxygen attack on chromium, right? Then you can draw the next step as H double bond O, chromium O minus, double bond. So just draw the complete part of here. Okay, right. Now, so due to the donation of lone pair of electrons on carbonyl oxygen, oxygen is with positive charge. Then which reacts with water. Here water acts as nucleophile and oxygen of water attack on electrophilic carbon. Then the electrons or pi electrons moves onto more electronegative oxygen to compensate positive charge on it. Okay, now here you can draw the next step as like this. Okay, I'm not drawing the complete structure here. Okay, just do it is the same. Now once again the hydrogen cleaves as H plus to compensate the positive charge on oxygen. So here in the next step OH, okay, and here we have chromium. Once again the proton cleaves here and chromium complex just moves out. Okay, chromium oxide, and here you just having the remaining part as C double bond O OH. So this is the mechanism involved in it. Okay, right. Now the next step, we are going to look at the next step or the next step of the reaction. So here C double bond O CH3. Now just remember that it is a name reaction. We can call it as hollow form reaction. Okay, here NaOCl, whereas sodium is in plus oxidation state, OCl with minus oxidation state. So OCl minus can abstract the acidic proton. We know that whenever the hydrogens on alpha carbons of carbonyl compounds are considered as acidic in nature, so that's why they can easily cleave as protons. Okay, so this bond electrons moves here, then the pi electrons moves on to oxygen. Now just draw the next step here, O minus double bond CH2, right? So here what happens, the proton is takes up by OCl, then it goes as HOCl. Okay, now it reacts with HOCl, that the negative charge goes here, this double bond attack on hydrogen, and once again OCl minus cleaves from it. Okay, then Oh, sorry, not this. So here, then so it's going to attack on chlorine, and it just cleaves OH minus. So base can be cleaved from it. Okay, so C double bond O, CH2, Cl. So the same steps takes place here to produce pH, C double bond O, CCl3. Okay, so that is haloform reaction, and haloform test is used to identify methyl ketones, that is C double bond O, CH3. Okay, when an unknown organic compound has this spot, whenever it is reacting under haloform test conditions, reaction conditions, then they will produce this product. Okay, right. And next case, so further hydrolysis, what happens here? So OH minus ion, which cleaves here, attacks on it. Okay, attacks on carbonyl carbon. Then the pi electrons moves on to oxygen. In the next step, they move again here. Then the cleavage of C minus takes place. Okay, so in this case, you will get C double bond O, OH. Then you have another part, that is CCl3 minus, so which abstract proton from the reaction conditions to produce CHCl3. Okay, so we have carboxylic acid product from that ketone. Okay, right. And third reaction, what is the third reaction here? So just take it. The next step of the reaction is CH2OH, which is reacting with PCC. Now, do you know the composition or the structure of PCC? Pyridinium chlorochromate. Okay, just remember that you need to practice more and more. You should have the patience while solving organic problems. Okay, you need to draw each and every step of the mechanism. Then only you cannot get the confusion, and you will give the correct steps of mechanism, and you will give 100% correct product of it. Okay, so that's why it is important to follow each and every step of the mechanism. Okay, right. Now just try to look at here. O minus pyridinium plus, so which is considered as PCC, pyridinium chlorochromate, right? In a first step, the lone pair of electrons on hydroxyoxygen attack on chromium, then double bond electrons moves on to oxygen. In a next step, the electrons moves again to make carbonyl group here, or double bond with chromium and oxygen. So in the next step, chlorine cleaves as Cl minus. This is the sequence of steps you need to follow. Okay, right. Now in that you can get this. So H, here is a H, O, chromium, double bond O, here O minus, pyridinium plus. Okay, right. In the next step, the Cl minus induces the reaction, that is Cl minus can induce to cleave that proton. Okay, and this bonded electrons moves on to chromium, and the pi electrons moves on to oxygen. So in this case, what you get? Simply you will get CH double bond O. Okay, only aldehyde is produced. Okay, whenever the primary alcohol reacts with PCC, pyridinium chlorochromate, the limited oxidation takes place. Okay, it is not going to convert into further into carboxylic acid, because limited oxidation takes place with PCC and also PDC, pyridinium dichromate. Okay, so just remember that. Okay, and the fourth option, which we have given, that pH. So same kind of mechanism you can see with that chromic acid. So here is a OH, Mn. Just draw the complete structure of Mn, O4 minus here. Okay, so same, the lone pair of electrons and oxygen attack on Mn, and double bond moves out. Okay, in further steps you can see, you can get the complete mechanism. Okay, so if you are interested, I can give it here. Most of the time my lectures will need extra time. Okay, so most of you guys need shortcuts and short answer. I can say that you can get shortcuts and short answers and short ways only when you understand, when you have the strongest command on basics. So that's why my request is to you that first learn the basic concepts. Okay, so if you know these mechanisms on these accelerations, in the next after watching these videos, then you can solve by just looking at the options. Okay, right. So that's why, so please stay with me here. Now in the step you can get this pH, H, and Mn, O minus, K plus. Okay, so proton cleaves from it to compensate positive charge on it, pH. So just do the same thing here, Mn. Okay, in the next step what happens? So simply once again same proton cleaves from it. Here is a formation of benzaldehyde. Okay, right. In a further step, the benzaldehyde again reacts with KMnO4. So you can see how it can react. So the lone pair of electrons on carbonyl oxygen attack on Mn. Okay, then here double bond O, Mn. So here you can see double bond O, and here just write K plus, O minus, O minus. Okay, so oxygen is positive charge. In the next step, water can act as nucleophile in the reaction conditions, in acidic conditions. So lone pair of electrons attack on electrophilic carbon, and the pi electrons moves onto oxygen to compensate positive charge. Okay, so here you can see OH, right, and this is the step you can get. Right, in the next step, the base can attack this proton, and simply the Mn cleaves from it. So you are going to get OH, C double bond O. That is, whenever the primary alcohol reacts with KMnO4, it converts that primary alcohol into carboxylic acid functional group. So what is the correct answer for it? Which is not going to give carboxylic acid? So simply third option. That is, the primary alcohol, whenever reacting with PCC, only gives aldehyde. Okay, not carboxylic acid. Okay, right. Now the next question. The amine that reacts with Hinsberg's reagent to give an alkali insoluble product is, it is very, very important. Okay, so you need to have the command on Hinsberg reagent. Okay, so Hinsberg reagent is used to identify or differentiate amines. Okay, so do you know the structure of Hinsberg reagent? So then simply pH. So this is the structure, and what its name? Benzene sulfonyl chloride. Okay, benzene sulfonyl chloride. Now we can see the reactions with amines. Primary amine, for example, primary amine reacting with Hinsberg reagent, what happens? The lone pair of electrons on nitrogen of amine attack on the sulfur, so simply cleave Cl minus. Okay, so or NH. So here once again just take the second step. Okay, so here you can see nitrogen with positive charge because it donated its lone pair, then H plus cleaves from it. So simply Cl minus H plus as HCl. So HCl cleaves from it. In the next step, NH, yes, double bond O, pH. Okay, right. And here we can say that this compound is soluble in NaOH. That is, it can undergo basic hydrolysis. So what the name of this? Can you say? N-alkyl. Here you can see N-phenyl. Okay, so N-phenyl benzene sulfonamide. Okay, so that is the name of it. And simply, when you add sodium hydroxide, aqueous sodium hydroxide, what happens? So here, the water cleaves from it. It produces pH, S double bond, just draw the next step here, N or. Okay, so this is N minus, Na plus. So you can get sulfonamide salt of sodium. That is simply the product of Hinsberg's reagent whenever reacting with primary amine gives or simply produces a salt which is soluble in that sodium hydroxide. Okay, so primary, just look at the options. This is the secondary one, and here it is a tertiary amine, and here it is primary amine. So here it is primary amine. We can simply eliminate first, fourth and third because they are primary amines. They dissolve in alkali. Okay, but here we need to find insoluble product. Okay, now we need to check for secondary and tertiary amines. How they can react with given Hinsberg's reagent. Okay, now just take a secondary amine reacting with same. So the lone pair of electrons here attack and Cl cleaves from it, and so completely HCl cleaves from it. Then you can draw the next step as or. So this is the product you can get whenever the secondary amine is reacting with Hinsberg reagent. So here, when you apply NaOH, is it going to react? We know that NaOH is a base, and here the product which is formed here is also base because the nitrogen is not having acidic protons. So if nitrogen is connected with protons, base can react with this proton and produces salt. But amine doesn't have any acidic protons on it. That's why it is not going to dissolve in sodium hydroxide. Okay, listen carefully. That's why here we can choose the first option as the correct answer because secondary amines are insoluble in alkaline solutions. Okay, now try to check the tertiary amines, how they react. Okay, so this is the complete information about what we say Hinsberg reagent. Okay, so from one question you are going to get all the concept. That's what I said. So here Hinsberg reagent, just write. Now what happens, the lone pair of electrons, is it going to attack on this because the groups are bulk, because the nitrogen is connected with 3 alkyl groups, so it is very bulk one, and it is not going to attack on the sulfur of that Hinsberg reagent because steric repulsions are just involved here. Okay, so in this case, when you add base, so the base can react with this Hinsberg reagent first. Okay, then here you can get pH O minus Na plus. Okay, salt of benzene sulfonic acid is produced, right? And now this salt of benzene sulfonic acid reacts with tertiary amine. Okay, so as we said, tertiary amine is insoluble in AOH, but soluble in HCl. Just remember that. Okay, so whenever this tertiary amine is taken in HCl or acidic solution, what happens? The lone pair of electrons on nitrogen attack on HCl, produces simply amine salt, amine HCl salt. Okay, so from this analysis we can simply say that only first option is the correct one. Here the tertiary amines are not going to react with Hinsberg's reagent. Secondary amines can react with Hinsberg reagent and they produce insoluble product in alkaline solutions. But here tertiary amines are not going to react with them. Okay, so in that case, first option is the correct answer. Okay, right. And next question. Which structures of proteins, now third one, which structures of proteins remains intact during denaturation process. So to give answer for this problem, first we need to know what is denaturation. So we know that primary, secondary, tertiary and quaternary proteins are there. Protein structures are there. So in secondary, tertiary, quaternary protein structures, we can see hydrogen bondings, which are considered as weak bonds. Okay, so the denaturation is the process of breaking weak bonds like hydrogen bonds in proteins. So we can see the hydrogen bonds in between the what we can say the amino acid sequences of secondary, tertiary and quaternary proteins. Okay, so that's why they can be cleaved, but the denaturation process is not applicable on primary proteins because primary proteins are having lack of hydrogen bondings. Okay, so simply what is the correct answer? Second option, because denaturation process is used to break weak bonds like hydrogen bonds, and these weak bonds are more possible or more naturally occur in secondary, tertiary and quaternary proteins, but not in primary proteins. That's it. Okay. Okay, next question. So the polymer that is used as a substitute for wool in making commercial fibers is. So these are memory based type of questions. So when you discuss, when you study, if you remember them, then you can simply give the answer. Okay, there is no need, there is no concept involved in it. We need to remember these kind of questions. Okay, right. And here the correct answer is polyacrylonitrile is used as a substitute for wool in making commercial fibers. Okay, next question. Artificial sweetener stable at cooking temperature and doesn't provide calories. So here we can see aspartame and sucralose both doesn't provide calories, but aspartame is unstable at cooking temperature, whereas sucralose is stable at cooking temperature. That's why, which is the correct answer? Simply option 3 is the correct answer. Okay, so just read the questions carefully. What is required and what is asking us? If you understand the question properly, then you can I can say that you can solve 50% of question if you understand that particular question. Okay, right. Next one. The liquefied gas that is used in dry cleaning along with a suitable detergent is. Okay, so if you want to get a guided, a careful coaching, so just visit and join chemmasters.online website for JEE and NEET chemistry courses. Okay, right. Now the liquefied gas that is used in dry cleaning along with suitable detergent is. So the correct answer is here not CO, that is CO2. So liquefied CO2 used in dry cleanings. Okay, so option 4 is the correct answer. No conceptual analysis required for that. Next question. The hydrolysis reaction that takes place at the slowest rate among the following is. So here we need to check all the questions. Okay, right. Now just look at the first reaction. So just remember that primary alkyl halides, just say primary alkyl halides involve in SN2 binucleophilic substitution reactions. Okay, right. And so what we can say, primary. Now secondary alkyl halides. So secondary alkyl halides can also involve in SN2, sometimes in SN1. So in major cases it is SN2. Okay, right. And tertiary alkyl halides undergo SN1 mechanism. Okay, right. And just look at the first one, first reaction. Here you can see we have chlorine here, and in the product what happens? OH is simply substituted this chlorine. Okay, so what kind of mechanism involved in here? We can say that nucleophilic substitution reaction. OH minus can act as nucleophile and Cl, which is cleaved as Cl minus. Okay, so nucleophilic substitution. We know that the direct nucleophilic substitution reactions are very rare on aromatic rings. Okay, and the direct substitution reactions are only possible whenever the benzene ring is directly connected with a strong electron withdrawing groups. Okay, but here you can see methyl group is moderate electron donating group. That's why the nucleophilic substitution reaction is impossible here on this reactant. Okay, so the hydrolysis reaction is slowest in option 1 only. Okay, so here you can see in the second reaction it is primary halide, that's why SN2 reaction takes place, and here also primary halide and SN2 reaction takes place, and here primary halide and simply SN2 substitution takes place. Okay, so the first option is the correct one because that nucleophilic hydrolysis is impossible on benzene ring with electron donating substituents. Okay, right. And next question here. When vapor of a secondary alcohol is passed over heated copper at 573 Kelvin, the product formed is. So first thing, and what we just asked, the secondary alcohol. Now, can you draw the secondary alcohol? So just draw here CH3 OH. Just remember that if you draw the complete structures, you will get an idea. Okay, so here we have copper heating at 573 Kelvin. What should happen? So simply metal dehydrogenation here. So loss of H2 gas takes place. Okay, loss of H2 gas takes place and produces ketone as the major product. That's it. Okay, next question. The major product C and D formed in the following reaction respectively or. Now, so just look at the reactant. If you look at this reactant, it will just looks like difficult. So that's why we need to draw in it expanded structure. Then you can get an idea how the reaction mechanism takes place. So this is expanded structure. Now applying hydrogen iodide. Now the lone pair of electrons on this ether oxygen attack on H plus and it removes I minus. Okay, so in the next step what happens? So simply here is the H plus. Okay, now so this is the structure you can see, right? I have given a line drawing. Okay, right. So loss of proton takes place. So this is a step, and in the next step, oh sorry, now before going to lose this proton, it is not going to cleave. So simply here we have I minus, right? So this I minus can act as nucleophile and it can attack here or so here. Two possibilities are there where it can attack. That is the question. For example, before going to attack this, if the cleavage takes place here, you can see a tertiary carbocation which can be stabilized with hyperconjugation and which is more stable. Okay, and if the cleavage takes place from here, what you get? So simply primary carbocation. We know that tertiary greater than secondary and primary carbocations in stabilities. That's why I minus attack here only. Okay, so in this case what you get? So simply just look at this is the correct products. These are the correct products and second option is the correct answer. Okay, just remember the basic point. We need to look at the stabilization before going to attack of that I minus. Okay, right. Next question, match the oxides. So here the first one is Na2O. Okay, can you draw the ionic forms here? We know that sodium is in plus, so 2Na plus, O2 minus 2. So we know that O2 minus 2 is a strong base. Okay, which has high tendency to abstract protons. We know that whenever a substance abstracts protons, considered as a base. Okay, so that's why Na2O is a base. Now, Al2O3. Al2O3 is considered as amphoteric in nature. Amphoteric means, so just like amphibian. Okay, if you look at the frog, which can live in water and on earth. So like that, Al2O3 can act as acid and also a base. Now just try to check it, how it can act as acid and base. Al2O3, whenever reacting with acid like HCl, it produces AlCl3, aluminum chloride and water. Okay, so here HCl is acid. Okay, oh sorry, here whenever it is reacting with, here Al2O3 is acting as acid. And in the next case, whenever Al2O3 reacting with base NaOH, it simply produces sodium aluminate. So OH taken 4. That's why here it is acting as base. Okay. So in both the cases, Al2O3 simply, that means in both the reactions we can see that in one reaction it has acid, in one reaction it has base. Okay. So that's why we can simply say that here aluminum Al2O3 as amphoteric in nature. Okay, that's right. So what I just here, did you get the confusion? Here HCl is already acid. Okay, so Al2O3 is base. NaOH is base. That's Al2O3 is acid. That's it. Okay, so simple. I just given reverse statements. Sorry for that. And next N2O. Right. So N2O is completely neutral. It is not going to react with base and not going to react with acid. That's why N2O is neutral. And Cl2O7. So whenever Cl2O7 is taken in water, it produces HClO4 minus. Okay, so which turns blue litmus to red litmus. We know that a compound, if it converts blue litmus to red litmus, it is considered as acid. So that's why HClO4 here, that means Cl2O7 act as acid. Okay, right. And next question. Match the catalyst with the process. So next question. V2O5. So what is the correct combination of it? So no need of explanations. Just look at directly here. Oxidation of SO2. That is the thing. Okay. Oxidation of SO2 in the manufacture of H2SO4. And titanium tetrachloride and the AlCH3 trice is used in polymerization of ethylene, that is called as Ziegler-Natta catalyst. Okay, very popular one. And palladium chloride is used in the oxidation of ethine to ethanol, and nickel complexes are used in polymerizations. Okay, so those are the combinations, and just take it. And next question, the most stable carbocation among the following is. So just try to expand their structures. Now H plus, here CH3. Okay, and here we have carbon, on that carbon connected with 3 methyl groups. Okay, so better to draw all of them. Right. Now here we need to look for the hyperconjugations. 1, 2, only 2 direct hyperconjugations can be seen. Okay, now just draw the second case here. So for this CH2, okay, so 2 hydrogens. For this carbocation, you can see 4 hyperconjugations. Now just look at for this third one. Okay, so H and H. Okay, here you can see 1, 2, 3, 4, 5. So for this 5 hyperconjugations, and for this you can see 4, and for this 2, and here you can see only 2. Okay, now which is having highest hyperconjugations? Third option. Whenever hyperconjugation possibilities are increases, then the stability of the carbocation increases. So simply third option is the correct answer. Okay, right. The next question: the alkane that gives only one monochloro product on chlorination. Here, what is it? Chlorination with Cl2 in presence of diffused sunlight is. Okay, now here the correct answer is the second one. So just try to draw the structure. So if you have the command and IUPAC nomenclature, then only you can draw the correct structures and you can give the correct answer. Okay, right. Now try to draw the neopentane here. So this is neopentane. Okay, so all are methyl group and all are same. Whenever chlorine on heating, in photochemical conditions under sunlight, it produces radicals. Okay, chlorine radical. Now what happens here? The chlorine radical attack on proton or one of the hydrogen of one of the methyl group. Then here is a formation of CH3 CH2 radical. Okay, now which is going to react with another chlorine radical and produces the final product as like this CH2Cl, that is monochloro product. Okay, so second option is the correct answer, because which we can see if this methyl hydrogen react with it, it can produce one, and here it is also one, and because here what we say, all the methyl groups are same, that's why the product is same. Okay, right. Now just look at the first one. So here 2,2-dimethyl butane. First draw the butane. Now 1, 2. So on the second carbon we have 2 methyl groups. So this is a structure. Here you can see these 3 methyl groups are same. So one of the hydrogen can be cleave and produce chlorine. Okay, and here CH2 is there. So which can also react with that proton, that means Cl radical, and produces the product. And this CH3 can also react with the chlorine radical, produces the product. Okay, the rates are different. We know that tertiary carbocation is more stable than secondary, which is more stable than primary. That's why here the chlorine which forms here will be the most stable product. Okay, but here you can see 3 kind of products are possible on first one. That's why it is wrong option. And here you just look at the N-pentane. Now just draw the N-pentane here. On N-pentane, CH3, the primary methyl group can react with chlorine radical and produces pentyl chloride. And here the secondary CH2 can react with chlorine here, or here the third carbon CH2 can react with chlorine. That's why 3 possible products are there, but rates are different. Okay, that is not the case, and that's why third option is also wrong one. Now just take isopentane. Now, so this is the structure of isopentane. Now here we have primary and secondary and tertiary. So we have 3 carbons with hydrogens. That's why the tertiary carbon can produce the stablest product, secondary carbon second highest rate, and primary carbon least rate of that product. So 3 products are possible from it. Okay, so but the question is the question is here, I'm sorry, I'm just giving here on these options, but just look at here, isopentane. So only mono product should be produced. So that is only possible on neopentane. That's why second option is the correct answer. Okay, right. Next question. In the following reaction, here we have given with propine, N-propine, reacting with red hot iron tube at 873 Kelvin, what happens? So simply 3 moles of alkyne react to produce substituted benzene ring, CH3, CH3. Okay, just try to expand them, draw the expanded structure, then only you can get an idea. Okay. So as I always said, it is very important to draw each and every structure while finding the correct product through the mechanism. Okay, so this is the product you can get or you can obtain. Now just try to find the sigma bonds. Here 4 sigma bonds, and here 4. So 4 plus 4. Here 4. So total 12 sigma bonds. Now 1, 2, 3, 4, 5, 6. So plus 6 sigma bonds of benzene. So total 18 sigma bonds are there. And how many pi bonds are there? 1, 2, 3. So 3 pi bonds are there. So total 21 bonds are present. So first option is the correct answer. Okay. Next question. Aluminum chloride in acidified aqueous solution forms a complex A in which hybridization state of aluminum is so here is B. What are A and B respectively? So this is the question. Now we try to write the reaction. Okay, AlCl3 reacting with water molecule. Just take 6 moles of it in acidic conditions. Okay, so it produces hydrated aluminum complex plus 3 Cl minus. Okay, so in this complex it is X or A, and in this complex aluminum is in plus 3 oxidation state. Okay, in general aluminum has 3s2 3p1 electronic configuration. Now just try it. So okay, so here 3s2 3p1 3d0. Now whenever aluminum is in plus 3 oxidation state, you can see 3s0 3p0. So empty orbitals are available, empty valency orbitals are available. Okay, now so here H2O, 6 H2O molecules can coordinate. Okay, so here sp3d2, so sp3d2 hybridization of it. So first option is the correct answer for it. Okay, got it. And next question. If you get any confusion, you can also comment on the video and I will explain. Okay, right. And I can say, so while premiering this video on YouTube, so I will be available on live chat. You can chat with me. Okay, if you get any doubt on that premiere playing. Okay, right. Which of the following compound is used in cosmetic surgery? So there is no need of conceptual analysis because it is a memory based type of question, and silicon is the correct answer. Okay, next question. Identify the incorrect statement. The scientific and technological process used for isolation of the metal from its ore is called metallurgy. This is the definition of metallurgy. Correct statement. Minerals are naturally occurring chemical substances in the earth crust. It is also correct statement. Ores are minerals that may contain metal. This is the wrong statement because mineral and ore are different. Okay, what is mineral? Already second statement is saying that minerals are naturally occurring chemical substances in the earth crust. What is ore? Simply if that mineral gives profit on its extraction, then that mineral is considered as ore. That's why ore and mineral are different. Okay, ore is a profitable composition of a mineral, right? So mineral is simply which can available on earth crust. So they are different. So third option is the wrong one. And gangu is an ore contaminated with undesired material. It is the correct statement. Okay, so our answer is the third one. Next question. A compound X upon reaction with H2O produces a colorless gas Y with rotten fish smell. So gas Y is absorbed in solution of copper sulfate to give Cu3P2 as one of the product. Predict the compound X is. So if you look at the final product here, phosphorus is there. So here the Y must contain phosphorus in it. Okay, so that is the thinking should we have whenever we are going to solve it in examination. Now in this case you can choose first option and third option, which is the correct one. Okay, in both of them phosphorus is there. Okay, so here the correct one is Ca3P2. Whenever it reacts with water, then it produces calcium hydroxide plus phosphine PH3. So this phosphine is having rotten fish smell. Okay, so the correct one is the first option. Now copper sulfate, which is reacting with here, what is Y? So pH3 is Y, okay? So pH3 produces Ca3P2 plus H2SO4. Okay, right. That's why first option is the correct answer. And now, so this Ca3PO42 cannot produce calcium hydroxyphosphine, cannot produce phosphine while reacting under hydrolysis of it. Okay, so that's why first option is only the correct one for it. And next question, which of the following oxo acids of phosphorus has strongest reducing property? To give answer for this problem, we need to know the structure, possible structures of given oxo acids of phosphorus. Okay, so focus on structures of sulfur, oxo acids of sulfur and phosphorus. They are very important for competitive examinations. Okay, right. Now, the reducing property of oxo acids of phosphorus depends on the number of phosphorus hydrogen bonds. Just remember this. Okay, now try to draw the first one, P. So always one of the oxygen must be with double bond O. Okay, so just do that, and now the remaining will be OH and OH here. So this is structure. You can see no direct phosphorus and hydrogen bonding. And next look at the second one, H3PO3. Now P double bond O, H, OH and OH. Here only one pH bond is there. Okay, now just look at the third one, P double bond O, one is OH, and here you can see two direct pH bonds are there. Okay, and fourth one, H3PO4, P double bond O, so H, H and H. No pH bonds are here on this H3PO4. As I said, if the number of pH bonds are increasing in oxo acids, then their reducing property increases. So, which is the correct answer? Third one is the correct answer, because which can donate their hydrogens as protons. Okay, so that's why if number of pH bonds increases, the reducing properties of oxo acids of phosphorus increases. Just remember this concept. Okay, next question, identify the correct formula of oleum from the following. So simply H2S2O7 is the oleum formula, and just try to know its structure. As I said, just know the structures of sulfur oxo acids. Okay, along with the phosphorus, they are very important for your competitive purpose. And next question, here, when neutral of faintly alkaline KMnO4 reacted with potassium iodide, iodide ion is converted into X. So what is X? So simply in alkaline conditions, so series of reactions takes place. MnO4 minus, so under alkaline conditions, alkaline hydrolysis, by just taking 3 electrons produces MnO2 plus 4 OH minus. So just multiply with 2 to make it stoichiometrically balanced. Okay, now I minus reacting with 6 OH minus, and then produces IO3 minus plus 3 H2O plus 6 electrons. Now what is the complete reaction here? 2 MnO4 minus plus I minus plus H2O produces IO3 minus plus 2 MnO4 plus 2 OH minus. So IO3 minus is the correct answer. Okay, and next question, the crystal field stabilization energy for the given complex COCl6 4 minus is 18,000. Then what is for COCl4 minus 2? So the simplest question here is, we need to look at the geometry. For the first compound, it is octahedral. For the second compound, it is tetrahedral. We know we have the relation between here the crystal field stabilization energy, that is delta T, which is equal to 4 by 9 into delta 0 of octahedral complex. This is for tetrahedral complex and this is for octahedral complex. Okay, now just substitute the value here, 4 by 9 into 18,000, you will get 8,000. So option, where is that? Fourth option is the correct answer. Okay, so you are going to get all the previous year papers with conceptual analysis like this on NEET and JEE examinations. So please stay tuned and just do subscribe, like the video, share the videos. Okay, your responses. If I get the huge response, I will continue. So response is very important. And at the same time, if you want to get a caretaking guidance and coaching to get 100 percentile, 100 percentile from chemistry part of JEE NEET examinations, you can also visit chemmasters.online website and you can join the courses. Okay, thank you very much.